Hi, I'm Kate Donahue, and I'm going to be presenting joint work with Solon Barocas entitled Better Together, How Externalities of Size Complicate Notions of Solidarity and Actuarial Fairness. So let's start out with a motivating example of car insurance. Say there are a group of people that each want to purchase car insurance, and each is either low risk or higher risk. So given a certain group of people, the insurance company calculates the break-even amount of money they would need for the total premiums. And so the key question is, how should this total burden of premiums be divided even among policyholders? So you could divide this evenly. You could just split the premiums across everybody, or you could charge riskier policyholders more, or you could do something else entirely. And you could have multiple goals here. One could be fairness, for multiple different definitions of fairness. One could be stability, that we want to potentially incentivize everybody to remain in the insurance pool. And let's make this a little more concrete. Let's say that we've got 1,000 people. 500 are lower risk, they have a 2% chance of suffering a loss per year, and 500 are higher risk, they have a 2.5% chance of suffering a loss per year. And each is insuring some good of value $1,000. So first, let's assume that the total premiums needed in an insurance pool is given by an expected value of losses. And so this table demonstrates sort of the possible pricing schemes you might expect. So the first row looks at the case where the low and high risk members are in separate insurance pools. So the total amount you need to charge is $30,000 in this case. And if we sort of take the expected costs, divide them among people evenly, the low risk group, each person will pay $20, and the high risk group, each person will pay $40. So the next row is when we pool the groups together, the low and high risk groups, and we split costs evenly. So the total amount you need to collect remains the same, and each person pays $30. So the low risk group sees their cost increase, and the high risk group sees their cost decrease. Of course, this isn't the only pricing scheme we could look at. We could also say in the pooled case, price proportional to risk. And you see in this case that the low risk group pays $20 and the high risk group pays $40. So we just recover the original pricing scheme, the original prices that if they were just in separate pools. And so the takeaway here is that this is a zero-sum game. If we give a lower cost to one person, this means that we have to give a higher cost to somebody else. And this is just because for expected value, the total cost is just linear. For any set of people, the cost of insuring the whole set is the same as the cost of insuring each person individually, so it's summed up over the entire group. But one question you might ask is, what if there are strict benefits to pooling? So what if the total cost of insuring a group is strictly less than the cost of summing each of the people individually? And basically what we're going to see is that this complicates notions of fairness. So in this work, we're going to ask the questions, how do externalities of size affect questions around fairness? So stability and fairness are well studied in an insurance context, but most of the literature we found is largely premised on expected cost, as we saw in the last example. Conversely, cooperative game theory literature studies things in fair division and stability, but it mostly focuses on charging higher risk players more, not necessarily goals of subsidization that you might see in this sort of insurance context. In this paper, we're going to use insurance as a case study. We're going to show that externalities of size is absent from this discussion, but it is a natural byproduct of risk pooling that creates some sort of important and also counterintuitive dynamics. So I just want to emphasize that insurance highlights these effects, but our theoretical results apply much more broadly. We're just using insurance as a motivating example. So I'll go over a literature view and then the model, and then I'll discuss our two main sort of results. One is sort of impact on solidarity, a notion in insurance, and another is an impact on actuarial fairness, another notion in insurance. So first I'll start with the literature review. So the first notion is solidarity, and we might think of a key question. So if people have differing levels of risk, should they pay the same in premiums? So a solidaristic viewpoint would say yes, that you should spread the cost of misfortune across the pool, and that prices should be the same or potentially just closer than different pricing schemes would suggest. And here the view is that it's not fair to charge people more for bad luck, including the bad luck of being at a higher risk. And so as an example, it might be the case that somebody who drives an older car is at a higher risk of damages, but they might drive an older car because of their income or their wealth, which aren't things we necessarily want to penalize somebody for. Conversely, another notion is actuarial fairness. And again, the same question, if people have differing levels of risk, should they pay the same in premiums? An actually fair sort of viewpoint would say no, that people should pay their own way. They should pay some price that doesn't depend on the riskiness or presence or absence of other people in the insurance pool. In this view, it's that differential pricing is necessary for a few reasons. One reason could be adverse selection, that low-risk policyholders should be incentivized to stay in the insurance pool, And this gets into some notions of stability we'll talk about in a little bit. Another is moral hazard, that policyholders should be incentivized to avoid reckless behavior. And the last notion is something about fairness. That could be that some believe notions of fairness are that people with lower risk should be rewarded for this lower risk with lower premiums than people who have higher risk. So both of these discussions tend to assume expected value notions of premiums, which gives linear costs. But from the insurance case, you can imagine that there are multiple reasons for externalities of size, say administrative costs, for example. In our example, we use insolvency-based pricing, which is an existing premium calculation method that involves the standard deviation of losses. But more broadly, our results hold for any submodular cost function. So insolvency-based pricing. You might say that the amount of claims is a random variable. So look at this plot. The x-axis is the total amount of claims in any particular year, and the y-axis is some probability distribution over this. And so if you charge the expected value, you run the risk of not charging enough. So you have more claims in any particular year than you have brought in premiums. And this could be problematic for the company. This could also potentially be problematic for policyholders. If the company doesn't have enough money, they might end up having their losses go uncompensated, which would be bad for them. So an alternative pricing scheme is to, instead of collecting premiums based on the expected value, collect up to some sort of percentile of claim values. And sort of the mechanism is that larger insurance pools have more cluster distributions, and so a smaller amount of this safety loading factor is needed. And this is the mechanism. This is a mechanism by which you can see sort of cost savings for larger pools. So now I'll get into the model. We're going to assume that there's some fixed universe of fixed number of people and level of risk, and that we have low risk and high risk policyholders. Low risk there are NL low risk policyholders with risk level RL, and NH high risk policyholders with risks RH. That we've got some fixed cost function from the insurance company that's a function just of these values. And so our question is, how is solidarity and actuarial fairness impacted by a model with externalities of size? And as I said before, you've got this notion of stability, and this is something we've borrowed from cooperative game theory literature. We say that an insurance pool is core stable if there doesn't exist a group of policyholders that all wishes to deviate and form their own subgroup. And this is motivated by potential market competition. And so looking at this diagram on the right, it could be that a group fails to be core stable if, say, all of the lower risk policyholders wishes to split off. But it could also be that some combination of lower risk and higher risk policyholders wishes to split off and form their own insurance pool. And what's interesting about stability is that you have to reason about every player's preference over every other player. And that an arrangement can be stable even if there are multiple players that are unhappy that would prefer some other arrangement. It's also not in general true that a stable arrangement could exist. So this is why it can be tricky to reason about stability in insurance pools. Let's first look at the impacts of this on solidarity. So before, this is the same table as before, where we had a zero-sum game. So this is the expected value premiums for two different groups. Next, let's look at how this changes with externalities of size. The first takeaway is that evenly splitting costs can financially benefit the lower risk group as well as the higher risk ones. So looking at this table here, you can see that the first row is when the low and high risk members are just in separate insurance pools. And the second row is when we've pooled the groups together. So the first thing you should note is that the total cost has decreased here. And this is just because of the insolvency-based premiums. We've total costs are decreased when you group two groups together. And here we're assuming we're going to split costs evenly. And you might expect, and it turns out to be the case, that the higher risk group benefits from this. They see their costs decrease from about $38 to about $31. But what's also interesting is that the lower risk group also sees their costs decrease from about $32 to about $31. And so sort of the benefits of being grouped together are outweighing the costs of having to split costs with this higher risk group. And this result builds on this past results. So it says that evenly splitting costs is core stable, so long as average costs in the pooled group is lower than the average cost for lower risk policyholders alone. So what we're saying is that if you can guarantee the low risk group doesn't want to split off, you can guarantee that any other combination of subgroups also doesn't want to split off. So in the diagram before, if you can guarantee the blue group doesn't want to split off, you can also guarantee that this subgroup doesn't want to split off. And it should be clear why this is necessary for core stability, but it's kind of interesting that this condition is sufficient. You might want to go one step further and say, what's the most we can subsidize the high risk group before we incentivize the low risk group to leave? And what we call is we define something called max subsidy pricing. And in this pricing scheme, you charge the low-risk policyholders the same price they would get a loan, and then you divide the remaining marginal cost among higher-risk policyholders. And so you see an example. This is the last row in this table here. So it's again the same example before. So the total cost is the same because it's pooled. But the pricing scheme, you see that the low-risk group pays about $32, which is the same as what they would pay if they were in a separate insurance pool. And the higher-risk group is paying about $31. And what's kind of interesting is that the higher-risk group is actually paying less than the lower-risk members, even though they're pooled together. And one result we show is that with max subsidy pricing, sort of the coalition, the setting where everybody is in the same insurance pool is core stable. So even though the higher risk group is paying less, it's not the case that the low risk group wants to and is able to split off to form their own group. So some high-level implications from this. We say that externalities of size provide some wiggle room for subsidizing the higher risk group. And that sort of solidaristic pricing schemes can offer incentives for participation of lower risk groups. So it gives you this stability result that you sort of potentially wanted. This doesn't mean you can always subsidize as much as you want. We give, with the max subsidy pricing, we give an upper bound on the most you can subsidize and still have this sort of stability result. So next I'll go to the impacts for actuarial fairness. So remember, actuarial fairness had the goals of I want to only pay my own way, and I want to pay some amount that's based on the presence or absence or riskiness of somebody else in the insurance pool. And so you might imagine some strong goals from the start. We'll start out saying that you need to have the prices we charge for everybody sum up to the total amount needed. And we'll start out by saying maybe the prices are independent of the number and risk of other people. So it shouldn't be surprising that you can't have these goals. If you have sort of strict benefits to pooling groups together, you can't simultaneously sort of exactly charge the total amount you needed and also charge somebody an amount that's independent of the presence and risk of other people. It just doesn't work out mathematically. So you might say, let's have some sort of weaker goals. We'll keep our efficiency requirement, and again, we want our stability requirement of not wanting people to be incentivized to leave. But let's say that we're wanting aligned incentives, and this is a sort of natural or sort of desirability goal that you might say that if I'm in an insurance group, I don't want to have an incentive to wish my other people in the insurance pool harm. This feels like an antisocial incentive. We would rather prefer that we want other people in the insurance pool to do better to reduce their risk. It actually turns out you can't achieve these three goals simultaneously either, which is kind of interesting. And here's an example sort of walking through this. So here we've got the sort of pooled, but in both cases, the groups are pooled together. And we're doing something called proportional pricing. It's not exactly important what it is, but it's an attempt to get solidaristic and an actuarially fair pricing scheme. So you can see in the first row, we're having this pricing scheme, and the higher risk group has a risk of 2.5%, and that the low risk member is paying about $28. Then in the next row, we've raised the riskiness of the higher risk members, and you can see that we've decreased how much the low risk group is paying to about $27. And so this is saying, like, as the high risk group gets more risky, the low risk group is paying less. And so you might say, all right, let's try and go for even weaker goals. Let's say that low risk policyholders are ambivalent about how risky their partners are. It turns out that you can achieve all three of these goals simultaneously. And this exactly gives this sort of solidaristic max subsidy pricing scheme as before. So this is what we had before, is that if you charge low risk policyholders the same price they would get a loan, and then divide the remaining marginal cost among the higher risk policyholders. And this table here is just showing the example where the low risk policyholders are just paying the exact same amount, and even though the risk of the higher risk policyholders is changing, they are not incentivized to leave. And so this is sort of a really interesting result, because you've got these original goals, the sort of basic goals for actuarial fairness, and you're showing that if you can't have them simultaneously. You must have this sort of antisocial incentive. And it motivates, we think, sort of the need to revisit the goals for actuarial fairness and sort of think about how we should divide the benefits of submodularity. So some broader implications. Basically, the high-level takeaway is that externalities of size complicates traditional notions of fairness in insurance. On the one hand, it helps to align the goals of low and high risk groups and gives more room for subsidization, but it also leads to impossibility or undesirability of achieving actuarial fairness as we commonly understand it. And so there are some broader implications we want to think about. So it's got implications beyond just insurance and scarce resource allocation. There are many situations where how we treat one individual depends on how we've decided to treat others. And reasoning about fairness is tricky here, and we think this opens new opportunities and challenges for thinking about fairness in this avenue. For more information, please look at the full paper. Thanks.